Hello guys, welcome to this tutorial. C programming variables exercise. So far we have covered the variable concept in C programming. So we have seen how to declare a variable, how to initialize, how to assign a variable, how to even modify the type of a variable with modifiers as we saw in the two previous tutorials. So please, if you have not yet watched that, you should go and work that back, please. It's very fundamental before we jump into what we are going to do here. So you should have at least watched those two videos on variables in C programming as we saw previously. So please, if you have not yet done that, go back and then watch that, and then come and let's go ahead for some practice. So in this tutorial, we are going to actually practice what we saw on those two previous tutorials on variables in C programming. So let's go ahead and see what is that all about, how to actually manage those variables in C programming. So as you can see here, I have the hello world program here. Remember this code as we saw previously, and then explain what's actually going on each at this level and so on. So let's go ahead and compile this program and just see what it shows out. Of course, we see here the hello world. Remember, so actually that's what we actually expect. So nothing strange here. Remember from our first program. So now, okay, a variable. We saw that. Let me just write something like this: int number. Actually, what am I doing here exactly? So what I'm doing here, I'm actually creating this variable called number of type integer. So you saw that this int is actually for integer type. So this number is for of an integer type. So in memory, 4 bytes will be reserved for this number. That is 32 bits. Actually, those 32 bits, one is for the sign, and the 31 remaining is for the data itself. Remember, as we saw in the previous tutorial, as I'm just from saying, please, you should have at least watched those two previous tutorials on variables in C programming. So I will leave the link in the description of this video so that you can go there and look for what is that all about. So this number is actually an integer that is 4 bytes in size in memory, in your memory, that's your RAM. So the space we reserve for that in memory label number there. Okay, so now you have declared a variable of an integer type by putting this int in front of this number. You're actually declaring this variable of an integer type called number. Also, one thing that I need to tell you, and that's very important, is that variables in C programming are case sensitive. Please, variables are case sensitive. That means if later on I'm declaring something like this called let's just say number like this, and don't think that these two variables are the same. No, these are different variables. Please, that's what we mean by case sensitivity, because this small n in C is not the same thing as this capital N. So it's very fundamental, it's very important that you should understand this concept of case sensitivity. That's what we mean by case sensitive. So C programming variables or function names are case sensitive, as we are going to see function later. Also, variables are case sensitive. Please, I'm insisting on that fact so that you should not go and confuse and maybe think that this number and this one are the same. At least you understand what I mean by case sensitivity. I'm just from explaining. So you see that this n is not the same as this small n. So that's what we mean by case sensitivity. So I hope it's clear, guys. So now let's go ahead and do something like this: number equals to 5. So actually what we're doing here is that we are actually assigning this 5 to this number. So this equal that you are seeing here is not actually the equal that you are used to. This in programming, in C programming, means assign. So you're actually assigning number 5 to this variable called number, that is store this 5 in memory, that is in 31 bit size, because one bit is for the sign. So remember, so store this in an 38 bit size in memory. So a label, memory label number. Please remember the case sensitivity is very important. Don't later on, don't change this. It should be exactly the same thing. That's lowercase. Please, it's very important. So now, so we are actually assigning this 5 to this number. So now if I want to print this number, I can just do something like this. Number equals to percentage %d. Also remember that printf prints only strings. Please, it's very important, only strings. So it cannot actually like directly print a number or a variable, something like that. So that's why we need to put what we call the placeholder. We are going to talk about the placeholder in the next tutorial, where we are going to talk about the input and output in C programming. So don't worry too much about that. So just remember that the printf function does not print the variable or a number directly like this. So we need what we call a placeholder, and each type of variable has its placeholder. So for integer it's actually percentage %d. So when we put something like this, then here we are going to put something like, we are just going to put the number here to actually represent this place, to match this placeholder called percentage %d for integer. For float, we are going to see what is the placeholder for float. That is, it will be something like percentage %f, but we are actually reached there. But I'm just from saying that you should not worry too much about placeholder for now. We're going to talk about that in the next tutorial, so you should not miss that. Okay, so let's save this and then just go try to print and see what it shows. You see here the number equals to 5. Actually, that's what we actually expect. So this placeholder percentage %d is actually for integer, so we will match this first percentage %d will match the first variable here. So, or a number directly, you can even put a number directly like this. Let me just put something like this, and then it's exactly the same thing. So there's no problem as far as that's concerned. So I hope you got the point from there. So now also what we can do is that you can actually declare a variable and initialize it directly like this. Put something like this, 25. So what we are actually doing here is declaring a variable called number and then initialize it to be 25. That is assigning 25 to it at the same on this same line as we are declaring this number variable. So we can do that. It's possible. So it's possible to do that. So now let's go ahead and try to print. Of course, you will see the same thing, nothing strange. Number. So if you print, you'll see exactly the same output. So you have 25. So also remember that we said a variable name should not start with a number. Please, you see that when I'm putting something like 5 here, you see that there's a problem, and if you compile this, you will have some warning like a variable cannot start, as you can see there. So a variable name should not start with a number or with a reserved word. Like for example, you cannot start a variable, you cannot create a variable to actually be an int. This will not work. It's actually, as you can see there. So a variable should not start with a number, and with some reserved word. It should not be a reserved word. That's a language reserved word. So it should be something. It should start with a letter. Please, not a number. At least with a letter, and then you can even, of course, put the number at the end. It does not there's no problem. And also remember the case sensitivity, please. It's very fundamental. Many beginners confuse with that concept of case sensitivity. They think that writing this number and then later on maybe capitalize it, and then they think that it should be, they expect the same output. No, it's not like that. So please, it's very important that you understand that. So now I think you get the, now later on, that is after writing some code, we can then change this variable to be something like this, and then you can of course even print it after changing. That means maybe you are doing some computation and then you want to change the variable to do some calculation and so on. You can of course change that later, and if you compile, we see that we have the number which is exactly the same thing, but it has changed. Now it's 89, so we can do that, can change later on. So this tutorial is all about showing you how to manipulate variables. So as we go forward in this course, we are going to see more, we're going to discover more variables and so on. So this is just actually to show you how to manipulate variable in C programming. So I hope it's okay for, we also see we have also seen the short modifier. So you can actually declare something like this, and we saw that the short is actually, as its name suggests, it's short integer, of course. So if you go there and print, you will have exactly the same output, and we gave the range between which this short falls. So as I said, you should at least watched the 2 previous tutorials on variables in C programming. So as I said, I will leave a link in the description of this video, so that you can go and browse and watch those videos, so that you can get the best approach in what we are doing here. So we can also have the long, as we saw, the long int. Yeah, so also we specify it, so don't you should at least go there and at least watch those previous tutorials. Okay, now as we can see there, the long, for the long is different. So now as you can see there, the placeholder, that's what I wanted to show you, that placeholder issue. So we are going to manage that in the next tutorial. For the long, the placeholder is actually LG, means long integer. So at least you should we are going to see that in the previous tutorial, so don't bother too much about that. We're going to cover that in the next tutorial. So as you can see there, now it's okay. So this actually is actually we gave the range within which a long integer will fall within. So all of this, that is short, long, in, and so on, is to manage the space, that is this for the size of actually the variable. So now I think that is okay for integer. Now we can go forward for float numbers. So to declare a float, just enter something like this, and then maybe decimal, something like this, and then just enter the float number there, something. So here we're actually declaring the float. It's exactly the same thing as the integer. So now, and to print it, you should just do something like this. So it's exactly the same concept. If you have understood the one form, as you can see there, I need to change this to float, of course, because I've changed that to, now the number does not exist, so I need to change that to float. Let's go ahead and compile that and see what is actually going on here. And as you can see there, we have the float there, so everything is just fine. Down is great. So it's exactly the same thing. Here we are just explaining the case sensitivity and so on. See, the only thing that changes is only the type, so remember that. So now, of course, you can even put a long float, there's no problem. So it's exactly the same concept as we explained earlier. So and we understand what the long means from the 2 previous tutorials, so you should watch that. So now that's how it is. As you can see there, it prints it like this, so everything is just fine. And the placeholder for float is actually %f, so it's not more %g, that was for integer. As I said, we are going to cover the placeholders in the next tutorial with as we are going to see input and output in C programming, so don't bother too much about that. So everything that you have applied in an integer is exactly applicable here for float. So for double is exactly the same thing. So but here we should put something like this. So now let's go ahead and compile. See that we have exactly the same output, but if don't just look at the output here because they are the same and we think that we say that this double is for double precisions. In fact, we specify, we focus, we explain what the difference between the float and the double in the previous tutorial. So from there you can actually get the point. So it's for double precision and the float is only for single precision. So now the placeholder for double is actually percentage %lf. So now as you can see there, so it's not more percentage %f because we are actually working with doubles. So the placeholders is actually percentage %f lf. So and also remember this /n. This /n actually means that is for the new line, that is after printing this number equals to this percentage lf, which will be replaced by the decimal, this decimal double. Now just go to the next line after printing this to the terminal. So go to the next line. So that's what this /n actually means. So now if let us remove it and see, we are going to see what is going to show how it's going actually to print that thing. So let's go ahead and do, and you can see there that after printing it just continue printing the what is in fact the prompt in the exactly the same line. So it did not go to the next line. As you can see there, here it prints and then go to the next line. So as I remove, now you can see that when it prints, it continue printing whatever in the same line. So as you can see there, so the /n, what we call, that's what we call the escape character. Also we are going to discuss about the escape character in the next tutorial, so don't worry too much about that. I'm just trying to explain you some what is its role there. So now I think that it's okay for variable how to declare initialize. Of course you can change it later on as we are going to practice. As I said, we are going to see more about how to manage to manipulate them. So I'm just doing this tutorial to just show you some basic concept, that is practice. So as we know that practice makes perfect, so that's why I wanted you to, because I wanted to explain the concept first before we jump into practice. Yeah, so that when we are coding and then we are declaring, assigning, all those things, you are actually understanding what is going on. So that's all. So now I've also seen the const qualifier. So maybe I want the value of pi to be, in fact the value of pi is 3.14. Yeah, now this pi is actually a constant. We know that pi will never change. So pi will never change its value. It will remain 3.14. Of course, this is an approximation, so it will not change. It will never change. Of course, pi is a float number. Of course, it's a float number, so you can even put a double, no problem. So now let's go ahead and try to print this and see and explain what is actually going on. So now let me just and then print. As you can see that we have pi, the value, and then it just prints out the value of pi, and this pi will never change its value. So we said that we can do this, can be very useful in the case you know that the value will never change. For example, as pi in this our case, so the value of pi will never change in this our case, so you can declare it as a const. And why? For optimization, as the compiler knows that the variable will never change its value, then it can look for a way to optimize your compilation, that is reserve some specific things to, like, this variable is constant, so we can optimize it. We cannot worry too much about it many times since it's actually a constant. And we said that as you declare a constant, you must initialize it directly So it's very important, as you declare a constant, you must initialize it directly. And later on, you cannot do something like this, like pi equals to, let's just say 3 dot, it will not work. So because pi is actually a constant, and if you try to compile this, you will see that assignment of read-only variable, so pi cannot be, it's actually a read-only, as we declare it like this and initialize it directly. So as I said, we must initialize constant that we declare directly. Of course, a constant can be a double, a float, or whatsoever. So now you have also seen the car. So to declare a character, you should do something like this, and then single quote, just put your character. So actually, to print that, you just enter C, and the placeholder for character is %C. So we can just say character, something like this, character equals to %C, then comma C. So it's going actually to print this for us in the terminal. So let's go ahead and try to print that and see what's the answer, the output. So now you can see that we have G here. So that's how character is actually works. So we, of course, we cannot have something like long car, or no, that long or short is only for for int and float and doubles. So you cannot have actually something like long car. No, it's not, it will not work. So please don't miss that. And also the same principle of case sensitivity is also applicable here, so don't confuse about that. And remember, it's single quotes, please, it's very important, single quotes. That's how we actually declare character, and the placeholder is %C, exactly the same principle. And we're going to talk a bit more about the placeholder in the next tutorial. Okay, so now, so far we have covered all what I wanted us to cover in this tutorial, and now we can then we have also seen the h define. So define something like this. Let me just say print, I don't know, I can just call something like p and then just call it print like this. Now what I can do is that I can this print, I can just replace it by p, and then let's go ahead and print something. Of course, this character does not exist, so let me just put something here to like a number. So let me just put a number here, and then of course the placeholder for number is %d. So now let's save this, and then let's go and see what is actually going on here. As you can see there, it prints that 8, but this p, is that actually the print function? No, how, what is that, and what's going on here? So now don't worry too much. So that's how the h define actually works. So as we said, the h define is something like find and replace. And remember that this is actually a preprocessor phase. So as we saw, the compilation process in C programming, that's the preprocessor, the linking, the object code, and so on. So you need to also watch that before you understand what's actually going on here. So now you see that this, before the code actually compiles, that's at the preprocessor phase, it will find all the p and then replace with printf. So wherever there is a p, it will replace it with a printf directly before we even go to the compilation, as we explained in the phase of compilation. So you should also watch that, so that you can get that is what's actually going on as far as compilation is concerned. So now you can see that we can replace this p with printf. So but of course you should not do something like this. It's not the good practices. You should do it for something useful, and then maybe you have a long text and then you just want to replace it with some, I don't know. And remember that there's no semicolon, so you should not put something like this. There's no semicolon here. This is not actually a C programming. Remember that this preprocessor is only for including library into our directory. The C programming starts just, in fact, those preprocessor distinct directives are not actually C programs. So is the preprocessor phase, as we explained in the previous some tutorials previously. So the process compilation, so you also have to watch that so that you can get what's actually going on here. So now that's how it actually works. So you can do whatever here. So just put word first, what you want to replace, and generally is in capital. So the convention state that it should be something like in capital. So you can just put something like long text here, and maybe just want to let's just say long text, and just want to replace it with something like LT. That means maybe long text. So just put something like this, where this an LT, replace it with long text. So let's say long text is something like welcome to, I don't know, to C programming. Of course, C programming. Now that's it. So where this LT, just replace it with welcome to C programming. So that's how it actually works. And of course, there's no semicolon, please. There's no semicolon. Okay, so now I hope you got the point from there. So now we also talk about the scope in C programming. So when I declare a variable here, call int, for example, say number equals to something like 9, this variable is actually in the scope. In this scope, see these braces, see these curly braces. So this number is actually within these close and open braces. So we say that this numbers is actually in a local scope. That's what we mean by local variable. So this number is actually a local variable. That is, it belongs to the main function. Of course, we are going to talk about the main function later on in this course, so you should not also miss that. So I'm just trying to explain you the scope concept in variable. So now, as I'm just from saying, this number is within these two curly braces, is in the local scope, in this main function. So of course we can declare a variable, just put number here. We can declare a variable out of this main function. Of course, we talked about the main function in the previous tutorial, so normally you should be familiar with at least understand what is that what it does here. As we said, all C programming should contain, C code should contain the main function. That's the starting point, and this return 0, we explained it also in the tutorial where we talk about our first C program. So you can also go and watch that so that you can get what is actually going on here. But we actually just explained, we are going to talk about function later on in this course. We are then going to understand the concept there. So we can also declare, of course, something like out here, and then call it float, something like let's just call it G. Of course, the name is not too explicit. Also, your name, in your variable name should be something very explicit, so that yes, you can, as you can see the number, we know that this should be actually a number, so it's very explicit. So now you can declare, of course, something here out of this main function. Out of this main function, you see that is out. Actually, this G variable is in the global scope. That means it can be used everywhere in any function, because later on we are going to declare some function, because here we have only one function. Since we have not yet covered the function concept, now we have only one function there, and this G is out of any function. So of course here we have only one function. So this G is actually in the global scope. That means we can use it in, if you have others function, you can use it there and then, but you should avoid that. It's very confusing and it can be source of some bugs. So you should not be used except for certain some circumstances, and then, but you can use it, but you should at least avoid when necessary, when possible, whenever possible, please. Okay, so I hope you got the point from local and global variable. So of course, if you go ahead and try to print that, you will get exactly the same. You get the expected output. Of course, number, we can leave it like that, and then try to compile. Of course, have it, but it's not in the You see, the global scope, it can be accessed in everywhere, in any function, everywhere. So, and also we are going to talk about the loop. You are going to see that local concept. So don't miss the next tutorial so that you fully understand the concept. So, guys, I hope you. So now, let me just try to do something like this and see what is actually going on here. And you see that it limits the decimal. We have here two decimal places because I put this dot 2f. So if you want to print a decimal number into something like two decimal places, just put, or if at n decimal places, just put dot n. If of course you are going to replace n with some number. So if I want 3 decimal places, I should just put percentage dot 3f. Now it's going to print 3 decimal places. So let's go ahead and save, and you see what's actually going to print. So you see that even if there are 4 numbers after the decimal, you see that it only prints 3 because of this dot 3. So that's how we can limit it. Of course, with long we can also do the same thing, that is dot 3 lf. Remember, the place that is the placeholder for long is actually lf. So if you want to limit, you should just put something like dot 3. Okay, I hope guys you enjoy this tutorial on variable and how to manage variable in C programming. Now in the next tutorial we are going to talk about input and output in C programming, and where also we are going to talk about this placeholder and so on, this escape sequence, this /n, what's that all about, and so on. So please don't miss that. See you next, guys. Bye.